Lesson 29, 15 Puzzle. To follow along with this lesson, download the project from the top of our lesson page at zoax.net. In this lesson, we program the 15 puzzle. The 15 puzzle consists of a 4x4 board of 16 squares. 15 of the squares are numbered 1 through 15, and the remaining squares left empty. Any square that is adjacent to the empty square may slide into that space. Since this is a computer programming tutorial and I wanted to represent the numbers by single digits, I used hexadecimal for numbering. For those who may not know hex, the letters A through F stand for the numbers 10 through 15. The objective of the puzzle is to get the numbers ordered right to left and top to bottom, so when the puzzle is in this position, it is solved. Let's move on to the code. After the header and includes, we define an enumeration called move. Recall that we covered enumerations in Lesson 26. Each of our enumeration values is an int that represents a direction and is assigned a char value for keyboard control. In Lesson 24 we explained that a char is just an int value with a more limited range. Next, we have our function declarations followed by our main function. In the main function we declare a two-dimensional array of chars to represent our board of numbered squares. We covered multi-dimensional arrays in Lesson 28. In the next line, we call the initialize board function. This function just copies the entries of a solved board into the game board that we pass in. After this call, the board looks like this. In the next line of main, we call the randomize function to make random moves to jumble the puzzle squares. Looking at the function, we see that it loops 1,000,000 times and generates a random number from 0 to 3. Which the switch statement translates to a call to the move function with a direction. We covered switch statements in Lesson 27. The move function, which we just called, looks like this. First, the function calls the locate space function, which sets the integers that we pass in to the row and column of the empty square. Next, we declare integers for the row and column of the square that will be moved into the empty square. This switch statement uses the move value that was passed in to adjust the row and column to the appropriate adjacent square. The last if makes sure that the move is valid. For example, if the blank is in the lower right corner, then both up and left are illegal moves, so we ignore them. Once the board is randomized, we begin our game loop. This loop is simply an infinite do-while loop which begins with a call to print board. This function runs over the 2D array of squares and prints them. In the next 3 lines, we print the control instructions and wait for the user to input one of the characters. At this point, the board looks like this. The keys on the left side of the keyboard correspond to movement directions. W for up, Z for down, A for left, and S for right. The char next move receives the character that the user inputs, and we convert that character to our enumerated type using the type conversion operator. We covered type conversion operators in Lesson 25. Once the character is converted, we call the move function. Note that we did not check for invalid input, and the move function ignores it. So for bad input, we just redisplay the board. This concludes the lesson.